Today we're starting chapter 10. Yes, we are skipping ahead to chapter 10. Today is actually a review of something that we did talk about last semester. We are going to be simplifying square roots. So our objective is to simplify and multiply radical expressions. We're also going to be bringing back the Pythagorean theorem. We'll talk about that again today, since that involved radical expressions. Square roots are written using a radical symbol, which is shown off in the top right corner here. A radical expression, or shortly called a radical, is an expression written with a root symbol. Something that might be new that we didn't talk about last semester is the radicand. That is the number inside or under the radical symbol. So if I were to put a number underneath the radical symbol, like a 2, 2 is called the radicand. All right, simplifying square roots. This is a property we've seen before. The square root of a times b is equal to the square root of a times the square root of b. We use this property to help us simplify. How it works is we take a number like 27 that we're taking the square root of, and we split it into the square root of two numbers. What's special about the square root of 9? That's a perfect square number. You can take the square root of 9 nicely. What is the square root of 9? 3. So that's why they wrote a 3 outside of the radical. The square root of 3 you cannot take the square root of, so it stays underneath the radical. So if you want to draw little arrows to what came from what, the 9 created the 3 that's out in front, and the square root of 3 stayed the square root of 3 in the back. And of course, we got the 3 and the 9 because 3 times 9 is equal to 27. Okay, another example would be the square root of 72. We can break it into the square root of 36 and the square root of 2. Again, the square root of 36 is a perfect square number, so we can take the square root of it. It becomes an integer, it doesn't give us a decimal or anything. So the square root of 36 is 6, so that's where we got the 6 that's out in front. The square root of 2 does not simplify, so it just stays the square root of 2 and went to the back. All right, so this says simplify the following. That means no decimals. Okay, so I said a calculator would be helpful, not because I want you to just type it into your calculator. If you type this into your calculator, square root 24, enter, it's going to give you a decimal. But a calculator can help you if you're not great with your multiplication facts or when the numbers get bigger. So 24, I think most of you probably could help me break down. What can 24 break into? Okay, why do I like 6 and 4 more than 8 and 3? So both of these would be appropriate. Does anyone think they know why I like 6 and 4 more? Why is it quicker to simplify? In the end, it really doesn't matter. But what's special about the number 4 that's not true about any of these other numbers? It's a perfect square. Okay, I would always look for factor pairs that involve a perfect square. Okay, so it's not wrong to use 8 and 3. We would just have to break down the 8 more. Right, but if we already have a factor pair that involves a perfect square, this is the square root of 6 times the square root of 4. Will the square root of 6 simplify down? No, but the square root of 4 is 2. And when we write these, which number do you think gets written in front? The 2. So it becomes 2 square root 6. The square root of 4 is 2, and any numbers not under the radical we put out in front. So if we break the 6 down, what does 6 break into? 3 and 2. Do we get a pair out of that? No. So there's no point in breaking down the 6 because it doesn't simplify. It's a good question. So that's our answer, 2 root 6. Now, if you want to do it fully the way we did last semester. Last semester, we didn't worry a whole lot about identifying the perfect square numbers. We just broke everything down all the way. You can still do that. When you break everything down, what are you looking for? Pairs. So we had a pair of 2s. That's why we had 1, 2 outside. The 2 and the 3 would both stay inside. They get multiplied back together to 6. So if you don't want to look for perfect square numbers, you don't have to. You can use the same method we were using last semester. What do you recommend we break 75 into?
25.
5 and 15.
3 and 25.
Why do I prefer 3 and 25?
Because 25 is a perfect square.
Because 25 is a perfect square number. If you use 5 and 15, that's not wrong. You would still get the same answer. I prefer 3 and 25 because I like working with perfect square numbers. So we would have the square root of 3 times the square root of 25. Will the square root of 3 simplify? No. So it stays the square root of 3. What is the square root of 25? 5. On number 3, can we think of any perfect square numbers that divide into 200?
10 and 20.
10 and 20.
10 and 20.
20 and 10 are not perfect square numbers. 2 and 100 would be correct. Which of those is a perfect square number? Which of these is a perfect square number? 100 is a perfect square number. Can we simplify the square root of 2? No, it has to stay the square root of 2. What is the square root of 100? 10. On number 4, for 45, somebody suggested we break it into the square root of 9 and the square root of 5. That will work. Which one simplifies? 9. The square root of 9 is 3. The square root of 5 does not simplify, so we leave it. The same property we just learned works backwards. So if you are multiplying 2 square roots together, you can multiply the 2 radicands, the numbers underneath, together, and simplify if possible. So this one example shown here, the square root of 2 times the square root of 7. We take 2 times 7, that would give us the square root of 14. That does not simplify, so that's why they left it square root 14. So it's the same property, just backwards. Another example before we work out our own, this one does simplify. If we take the square root of 2 times the square root of 8, 2 times 8 is 16, and 16 is a perfect square number. Okay, the square root of 16 is
4.
4. Now you'll notice they put the plus or minus sign. Yes, plus or minus 4. If you just put positive 4, that would be fine with me.
So if you put negative 4, it'd be fine too?
Yes, if you put the plus or minus, that's fine. Usually in this class, we are more concerned with the positive square root, not so much the negative square root. Those of you that go on to Algebra 2 next year, you guys will care about the plus or minus more there. On example 5, the first thing that we're going to do is multiply the numbers together. 7 times 5. 35. So this becomes the square root of 35. We then have to decide if the square root of 35 will simplify. No, because the only thing we could factor 35 into is back into 7 and 5. And neither of those will reduce. So we just leave it as the square root of 35. That's our answer. On example 6, first thing we do, multiply the radicands together. What do we get? 77. So this becomes the square root of 77. Will that simplify?
Nope.
No, it just breaks back into 11 and 7, which will not simplify. So we leave it alone. Number 7 is a little different from the ones we've seen so far. Jaden? 2 radical 15 is correct. Numbers in front of the radicands or radicals get multiplied together. What number is right in front of the square root of 5?
1.
A 1. Okay, we have to remember there's like a 1 here. So the numbers in front, 2 and 1, get multiplied together. That gives us 2. If it started outside, it stays outside. Underneath the radical, 3 times 5 gives us 15. Can we simplify the square root of 15? No, we cannot. So again, we leave it there. When we're just getting started, 5 is getting multiplied by 1. 5 times 1 is 5. That's outside the radical. Inside the radical, we're taking 3 times 3, which is 9. But what can happen here? We can simplify this radical. The square root of 9 is 3. So my answer is 53, right?
No.
No, what has to happen between these two? They multiply, and we get 15. Now, some of you thought it was crazy that I just wrote a 53 there. I see that happen. Don't be that person. All right, on these, we are just going to quietly raise our hands and volunteer an answer. And then if we need to go over it, how to do it, we will. Does anyone have the answer for number 9? Ken.
Radical 5.
What is it?
2 radical 5.
2 radical 5. Are we all okay with 2 radical 5? Okay. Any volunteers for number 10? Keon? 2 radical 2. Very good. Are we all okay with that? All right. Keon?
10 radical 3.
On number 11, are we all okay with 10 radical 3? All right. Did anybody figure out number 12?
Is it?
Keon again?
Oh, radical 7.
Poe? Radical 7. Is that it?
Radical 7. He's right.
Okay. Do we agree with that? We should. Those are all correct.
Number what?
On number 12, we have to break down 112. I'm going to take away number 11, so I've got some space to work. Now, if you want, you can be looking for a perfect square number that goes into 112. Knowing what the answer is kind of helps us with that. Somebody with a calculator, divide 112 by 7. Tell me what you get.
16.
16. Now, that's nice because 16 is a perfect square number. So that means when I rewrite the square root of 112, I can rewrite it as the square root of 7 times the square root of 16. Square root of 16 is 4. That's how we got the 4 out in front.
The 7 stays, so that's why you got the 7.
7 stays because it does not simplify. Now, if you wanted to break down 112 using, for instance, 2's, you could do that. Okay, 2 times 56. 56 would be 2 times 28. 28 would be 4 times 7. 4 breaks into 2 times 2. So you end up with, there's a pair of 2's all the way at the bottom that went off the screen. And there's a pair of 2's here. So 2 times 2 is 4. And what's alone? The 7. So 2 different ways of talking about the same problem. We get the same answer either way. We need to have a quick review of the Pythagorean theorem. A couple of people have already said a squared plus b squared equals c squared. What kind of triangle does this apply to?
Right?
Right triangles only.
How y'all know that?
Because she taught us.
We learned this last semester. It's got to be a right triangle. Which side has to be C?
The
The
longest.
longest.
The longest side.
Not the shortest.
It is called the hypotenuse. It's across from the
Right.
Smallest angle.
The base.
I mean, the smallest line.
The leg.
The smallest line.
the right angle. It's across from the right angle.
Yeah, the right angle. The longest side.
Yeah.
Do we all remember using the Pythagorean theorem?
Yeah.
No.
Yes.
I don't.
So for example, if we have a right triangle and we have 2 of the sides labeled and we're trying to find the other side, we have to plug them into the a squared plus b squared equals c squared.
So 3 squared.
So for this problem, 3 squared plus 4 squared
Equals c squared.
equals c squared. What is 3 squared?
9. Plus 16.
Good,
C squared.
good.
25 equals c squared.
Good. So let's all quiet down again. I'm glad you're remembering this. If you don't remember this very last step, which some people didn't do last semester, we don't want c squared. We want c. So we square root both sides. Now on this particular problem, will we have a radical in our answer? In our answer?
No.
No, because the square root of 25 is just 5. But it's possible on your homework and maybe on a homework quiz or on a quiz or a test that you will have to simplify the radical like we were doing in the examples in this lesson.
Do you take approximation?
No, that's a great question. No approximations. That's why we just spent a whole lesson simplifying radicals.